All right, we're back. Properties of matter, looking into the difference between physical and chemical properties. Should be a fantastic journey. Hang in there. We'll get going. You see a friend in the hallway, but the question is, how do you recognize him? Could be from his haircut, right? Could be that he's thin and short. Could be anything, his shirt, etc. But usually when you recognize people, it's because of their physical properties. And that, of course, is due to you describing it through your five senses, their scent, sight, what they sound like, etc., often refer to physical properties of matter. Going a little further into it, a physical property is a specific characteristic of that substance. So you can actually change a physical property of some type of matter without completely changing the substance. All right, but if we take a look at the skunk here, Mr. Pepe Le Pew, we know he has a certain odor. We know he takes up a certain amount of space, all right? Looking at things like density, whether it floats or not in water and that, and if it's a solid, liquid, or gas, or its color. For our skunk here, we know that it's black and white. Those are all physical properties. When we look at chemical properties, though, it's slightly different. It's the idea that an object might have the ability to change into a totally, completely new substance. Examples of that could be, let's look for example right here at this car. An old car with the paint rubbed off exposes the iron and the steel to the car, so it can possibly rust. The fact that it can rust really means that it can react with the air, the oxygen outside, and create a new compound that we call rust. It's actually, I believe it's iron 2 oxide is what rust is. But anyways, if an object can react with something, or if it cannot react with something, that explains its chemical property. It's all about whether it can or can't create and become a new substance. Think about burning something. If you burn something, you're actually reacting with oxygen, therefore stating that it can react with something. And if something decomposes, throw it in the garbage can and it starts to slowly rot. We know that after a banana that sat out for 5 months on the counter would no longer look like a banana. It would no longer be a banana. It'd be this sludgy mess that was now something else. That describes a chemical property. So if we think about shampoo, something simple that we use every day, physical traits of shampoo might be its smell, its color, if it's squishy, if it's thick, if it's slippery, all using our five senses to describe it. But if we look at the chemical properties, two chemical properties we're very grateful for is when we put it on, it doesn't burn our scalp. And when we mix it with water, it doesn't react and create some strange reaction that could hurt us. Okay, those chemical properties are things to be grateful for. Even though it's not anything happening, the fact that it won't react is also a chemical property and something that definitely benefits us. So now that we talked about physical and chemical properties, let's look into physical and chemical changes. If you change a physical property, the substance is still going to remain the same. For example, if my hair is blonde and then I dye it blue, afterwards, now that my hair is blue, it's still my hair, so it's been a physical change. What about a piece of paper? Cut that paper in half, it's still paper. It's just that it's now in two pieces. Those are physical changes. The substance is still the same substance, it just looks slightly different. For a chemical change, on the other hand, though, after a chemical change, you have a completely new and different substance. An example, again, would be back to the old car where it rusts. It was iron, now it's a mixture and a compound of iron and oxygen that we call rust. It's a completely new substance. What about something that decomposes, like cooked chicken in the garbage can? Oh, if you've ever smelled that after a couple days, it smells horrible and rancid. But the idea is that part of that chicken is no longer chicken anymore. It's reacted and created something new that gives off a horrible scent. Chemical changes, though, something new had to be going on there. Here's a good question for you. Is ice melting into water, is that a physical or a chemical change? Good question. The answer is that it's a physical change because ice and water and steam are all the same molecule of H2O. So therefore, it's just a physical change. It looks slightly different, but still the same pure substance. What if we're doing s'mores and we're toasting our marshmallows over a fire? So the marshmallow, put it in the fire, and you leave it in too long, and you end up with a pile of ashes there on your stick. Is that a chemical or physical change? It's definitely going to be a chemical change. That's no longer a marshmallow. The marshmallow reacted with oxygen in the air, O2, and ended up forming this pile of carbon. We talked about physical and chemical changes and physical and chemical properties. The last thing we do have to mention is that there is one other type of change, and that's nuclear change. And we'll cover that more in our nuclear chemistry unit. But anyways, in a nuclear change, you're no longer just breaking down compounds into individual elements like you would for a chemical change. The nucleus of an atom actually breaks down, and you create an actual new element. All right, which is pretty crazy to think about. But if you take something simple, something like uranium, all right, which isn't an atom bomb, when it goes through fission and breaks apart, it breaks apart into some different pieces, including polonium and some other elements. But the breakdown of that is amazing because it's not a chemical reaction. You actually created new elements from it. So pretty cool stuff and exciting. Hope you're excited for that unit. That's a crazy fun one. And last but not least, as a side note, radiation doesn't always mean that it's dangerous. Sometimes radiation is a good thing that's helpful, and sometimes it's not even dangerous at all. It's just there. So keep that in mind and keep on thinking. Once we get to nuclear chem, we'll tackle that topic too.